Chemical engineering is a challenge these students meet every time they enter the laboratory of their professor, Dr. S. Rama. The students and their teacher share the same attitude about their work.
Science and engineering is always exciting, right? Sure, you can make really novel materials, cool things which can impact life, society, but at the same time, as an academic, you can ask the fundamental questions of why and how things happen, which also really excites me. And not only the science part, I think you can see the effect it has on the students. So it has given them good research opportunities. You spend a lot of time with the students and trying to explain to them what research is and how beneficial it can be. And it's good to work with students on research problems, and I enjoy doing that as well.
That intrigue with discovery is a characteristic found in each student on every level, be it the research assistant, the undergraduate, or the graduate student.
I'm excited about everything science, really, but the reason I'm most excited is because I had great mentors over the summer. I have great mentors here, and I feel like I'm learning a lot and I can contribute a lot when I graduate, regardless of where I'm going. So that's what I'm most excited about, really.
That enthusiasm and passion has a powerful influence on positive change in the way we live. Scientists like these are always searching for new ways to improve our quality of life.
I'm studying how they behave in under different physical conditions, under different temperatures, pressures. You apply force to it. You try to treat it in every possible way, and you try to model how they would behave. A knowledge of that is good. And gels, as you know, are used in so many industries. Like you have the food industry, you have pharmaceutical, you have cosmetics, you have so much stuff. And if I know how they behave at a fundamental level, I now know that I have the tools to be able to translate it to a factory level or in an industrial level, to scale up that operation, to scale up how those properties would actually turn out on a real scale.
Devia's research find normally ends in product commercialization that, of course, allows the discovery to be made available to the public. It is a vital part of the research cycle. When one project is completed, the next one is launched, and each time, new students are caught up in the excitement of watching it all click.
We're measuring things with lasers, and so that's very small. And so now we want to take it to something, we want to relate that to measurements we make using machines, which is something that you can see and touch. And so learning how to bridge that gap between what we can't see and what we can see is very interesting to me, because I learned about it in class, but now that I see it in action, it's, I can relate to it more.
FAMU's chemical engineers are taking us into a future that is filled with promise.
Discovery is the journey, and you get the best of it. You get the best of it all, right? You get to see it go large scale, and that's a beautiful thing. That's a beautiful thing, I feel.
Congratulations, Rattlers!